In this interactive simulation, we're looking at a very simplified model for reactor economics just to demonstrate the principle. We'll do this for both a plug flow reactor and a continuous stirred tank reactor. What we're plotting here is profit on the y-axis versus reactor volume. And so the profit for this particular condition, profit per minute, is listed here, and then the conversion in the reactor. So you'll notice as the reactor gets bigger, the profit goes down. We're already at a high conversion, so a bigger reactor means we're paying more for reactor, and this is the cost of the reactor, and we're getting a small additional amount of product form. So this does not take into account separations costs, which can certainly be significant, but again, this is just a simplified model to demonstrate the idea. Instead of looking at profit, we can also look at what the concentration is in the reactor as a function of distance down the reactor. And showing the first order reaction, but we can also look at an autocatalytic reaction, and then having the product feed makes a significant difference in reaction rate since it's autocatalytic in the product. So the feed concentrations can be changed. Any unreacted reactant is assumed to be recycled with no cost. The cost of the product and the reactant can be changed, and of course that's going to change economics as well as the reactor costs. Clicking this box moves the black dot to the maximum profit, to the maximum point on this green curve, but the mouse can be used to move this dot anywhere along and get a readout of what the value for conversion and profit is. So let's look at this interactive simulation next. So here's the interactive simulation, and we're plotting profit. Notice then we can move this dot and get the readouts of conversion and profit. Or we can hit optimize, which sends us to the maximum value. Of course, as we decrease the cost of the reactor, then we can go to larger volumes where we're still making a profit. If we decrease the cost of the reactant, of course the profit increases, or if we increase the price of the product. Well, feed concentrations affect reaction rates and conversion, and then product concentration has no effect unless we're looking at an autocatalytic reaction. Now for autocatalytic, there is a significant effect because the reaction rate increases if we have product in the feed initially. For plug flow reactor, the behavior is similar, but the actual values are different, and the effect of the product is important. If we had no product in the feed for autocatalytic reaction, we get no reaction taking place. We can look at the concentration as a function of reactor volume. You can see most of the reaction is taking place relatively small volumes. So the main idea here is that there's going to be some optimal reactor volume for given feed concentrations, and of course for given values of reactant and product and the cost to build the reactor. And then we need to take economics into account, of course, anytime we're designing a reactor. And the objective here is to demonstrate how, as we change the variables, the profit is going to change.